Okay, Assalamualaikum. We are from Group 3, now presenting the simulation for experiment 6. So this is for the activity 1. We have a 3-phase transformer of 45 volt, for 45 volt here, and 50 Hertz. And we need to connect it to this both of wattmeter here and AC meter here to calculate the line to line voltage, and then connect it to the SCMs here, also to AC board here. For this activity we need to set up for this 3 resistor, which is 100 ohm for every resistor. For the active power value, we need to add this board of the value recorded. So let's run the simulation. So this is the value record. As you can see, for the active power we need to add this board value recorded. Okay, next, to calculate the reactive power, we need to change here to var. Then run the simulation. It is the same as the active power. We need to add this board value recorded to get the reactive power. Next, we need to repeat the step by changing the value of 3-phase transformer here is equal to 90, and for another one is 135. Let's see, we run here, get this value, change to var, to get the reactive power value, run. And lastly, for the 3-phase transformers, value is equal to 135. Okay. Run the simulation and get the value. So this is the value recorded for all the simulation circuit that we done for activity 1. That's all.
We will move to the activity 2, which are the star connected source with delta connected RL loads. So here are the figure for our experiment for the circuits, and for the simulation, here are the circuits. So in the circuit, we have the Vs, which are the 3-phase voltage source. We have 2 wattmeter, which will act as the 3-phase power meter. Then we use the voltmeter, the ammeter, and lastly, we have the resistive circuit, which are connect in delta connection. So for the first value of volts, we use the 45 volts and 50 hertz for the Vs. Now let's run the simulation. And here are the result for the 45 volts Vs. So the active power we have to sum the above wattmeter with the below wattmeter, and we will have the active power. Next, we have the voltmeter here, which will calculate the line voltage. Next, the ammeter here will act as to calculate line current, and lastly, the ammeter here to calculate phase current. So now we will calculate the power meter in the reactive power variable, which use the VAR. So we will change the variable here in VAR. So now let's run the simulation. We can see here the voltage line, the line current, and the phase current are the same. The difference are only the power in the wattmeter. Actually, we will have to ignore this power of reactive power, as the circuit the resistive circuit and do not have the reactance at all. So we can ignore this reactive power. So here the table show the full result for experiment in activity 2. So just now we just do for the 45 volts, and then for 90 volts the line voltage we got 61.90 volt. For the line current we have 0.98 ampere. For the phase current we have 0.62 ampere, and for the active power we have 112.40 watts, and for the reactive power is 0. As for the 135 volts, we have the line voltage is 92.90, the line current 1.47, the phase current is 0.93, and the active power is 253. As for the reactive is still 0. So that's only for activity 2. Thank you.
Okay, for next activity 3, star connected source with star connected RL load. So this is question we're gonna must to do. Then other simulation in Proteus. The figure shows responsive connection diagram for the 3-phase and 3-wire star connected with voltage source with a star connected with RL load. So we're gonna open the Proteus. So for the first simulation, you're gonna use a 45 volt and in the frequency of 50 hertz. And this how to connect the simulation for this star connected, and the resistor 100 ohm, and then for inductor use the 12.5 millihenry. We have a 3, both of them, and this for find the power, active power, and for this to find the VRY, and this for the find the VRN, and this for the find the current of the VRN. So we're gonna run it. So this our value, same as like this. We're gonna put the 40.4, 40.4 and 73.0 and 0.42, 53.8 for the watt. And for the find the reactive power, we're gonna change the power, this power. So we're gonna unactivate it, and to change it, only to change the watt to var, and this also. So we run it. So if you want to find the reactive power, we're gonna 3.6 9 minus with 40.5, and then we get the 2.1 for this, and then we gonna repeat again for 95 volt and 125 volt. So that's all for activity 3.